Assalamualaikum and good day to you, Dr. Ratna Carlos. We are from Group 8 and today we are going to present our lab assignment. So before we proceed with the presentation, we would like to introduce ourselves. My name is Clarence Lubin Champin and my metric number is 203240.
And I'm Ahmad Qayyum Fikri bin Ahmad Jazimin with metric number of 200,359. So today, our presentation is divided into 4 parts. Alright, the first part is the objectives. We will explain 2 objectives. Second one is system physical principle. The third one is circuit info. And the last one is multisim result.
So our group, which is Group 8, was assigned NAT light switcher as our lab assignment. So in this presentation, we will explain in details and further about our circuit. For the first one, we would like to present to you our main objective for this lab assignment. The first was to design and simulate a NAT light switch circuit using multisim. And the second objective is to demonstrate the operation and principle of the NAT light switch operation in the circuit through simulation.
So let's talk about system physical principle. So there are 5 steps that involve in our physical principle. But before that, let's talk about components and equipments. We use 6-volt DC power and we use resistors. There are 2 types of resistors, which is resistor and variable resistor. The LDR, we actually want to use that component, but we replace it with variable resistor instead of LDR. And then we have LED, we have single switch act as a main switch, and then we have transistors, 2 type of BJT transistors, which is NPN and PNP. Next, we have multimeter to measure our data, and we have multisim to run our project. This is the one that I talk about. We have 5 simple steps on how the circuit works. First step is we turn on the main switch. The second step is we adjust the variable resistor according to the specification of the resistor that will be explained on the next slide. And step 3, after the specs is applied to the circuit, the current will either flows or not flows to the circuit. When that happens, transistor amplify the output current and LED will turn on or turn off based on our specs given.
So before we implement our circuit, we did some research on the circuit and also we confirm our own theory. So the main objective is to switch on the LED when it's dark and switch off the LED when it's day. So the first theory, we can confirm that high voltage causes bulb to explode. Previously, we implemented a bulb instead of LED, and we like to build a bigger project. And even though we able to amplify and also minimize the current while using a high voltage, but the bulb still explode. So we decided to not use a high voltage and use this bulb to create a bigger project, and instead we use a simple circuit but with a little bit of changes. The second one, we use this variable resistors to replace LDR, like Koyum said just now. It is because of LDR is not available in multisim software. So we use this variable resistors instead. The third one is we implementing a switch where it is a requirement for this research where the night light must have a switch to indicate open and closed circuit or representing the on-off button. The fourth, we use both NPN and also PNP BJT, where you're using both of these BJT together forms a theory called the Darlington theory, and we will explain more on this on the explanation of our circuit. Next, we have the light and dark implementation of the variable resistor, where 0 to 49% represent light, 50% to 100% represent dark. And last, we use multimeter to confirm our own theory. Next, we go to the circuit information and explanation.
So this is our 3D circuit model. We have our source, LED, and transistor. Correct?
So basically, this is our circuit diagram. So we use a 6-volt power supply, and our power supply we uses direct current DC. So the DC will flow to our switching. So the switching will act as the open circuit or closed circuit, which is the on off, and then it will flow to our variable resistors and our resistors. Now the variable resistors is to control the atmosphere of the light and dark, and then the current will flow and minimize the resistor will minimize the current, and it will flow to the Darlington transistors. So that we did a research of using this Darlington theory and also just uses a single BJT. The comparison is that the Darlington theory proved that it produced a much greater output compared just using one BJT. So we uses the Darlington theory due to its efficient output. So and then we placed one resistors to control the current, and because it is a requirement to have a resistor before it goes through LED, which is to prevent the LED from being explode. Since the LED are parallel to each other, we uses only one resistors. Because we also did a comparison if using one resistors to a parallel LED and putting a resistor to each of LED of the LED produce the same output and input of the current. So therefore, we just uses one resistor to our circuit implementation.
All right. So this is
Now
our
we will show
circuit.
you our circuit simulation video.
All right. That's nice. So let's move on into multisim result. All right. So let's get to it. So this is the table of 10.1 and table 10.2. In table 10.1 and table 10.2, what we want to show, what we wanted to compare is actually on current on LED1 that flows through LED1. As we can see right there, when the potentiometer is at 40%, it indicates daytime, all right? So the value is 4.8 milliampere on I LED1 right there. Actually our LED need to have at least 5 milliampere to turn on. So on table 10.2, we can see when the potentiometer is at night, 55%, the current flows through LED1 is 5.32. So the LED will turn on. All right. That's all for the multisim part. So the advantages, first we have save energy, our circuit save energy because we have the switch on off. And second one, we use this Darlington's connection, helps to amplify the current output.
And the third, we have circuit efficiency since we implement some of the theory and also research. And the fourth is our design is unique and different compared to other group in terms of circuit implementation.
All right. I think that's all from us. Thank you.
Thank you.